This lesson is going to focus on matter, and more specifically the properties of that matter and how we measure it. So, what exactly is matter? Matter is anything that has mass and takes up space. Everything in the universe that you can think of, from your clothes to the desks in this classroom to this board that I'm displaying this on, everything is made up of matter. Okay? So, all matter takes up space, and if we think of it that way, all matter has volume. Okay? We learned what volume was in a previous lesson. Volume is anything that has mass and takes up space. So, matter makes up everything in the universe, and all matter has volume. So when we're talking about liquid volume, if everything has matter, so does liquid, right? So if we're looking at our liquid volume, we have to find a way to measure the volume of that liquid. And before, we learned about SI units, like liters and milliliters, and that's what we measure our liquid volume in. And we measure that in something called a graduated cylinder. And when we're measuring our liquids in that graduated cylinder, it's important that we look for something called the meniscus. The meniscus is a dip or curve in the water. So we have to get eye level with the graduated cylinder, and we have to see where the dip in that water comes to in the graduated cylinder, and that's where we measure from. So if we're looking at these pictures here, okay, we have a graduated cylinder, and it looks like the water is coming up to this line right here, to the 7. But if we look for the meniscus, we'll really realize that it's just one line below. So this is 6.8 milliliters instead of 7. Same thing over here in this picture. We don't measure from the straight water, we measure from that dip. That's called the meniscus. So if we're looking at a regularly shaped object, let's say a box or a book, okay, we can use what we learned in math, length times width times height. And this is a three-dimensional measurement, so our units are going to be in cubic meters, cubic centimeters, cubic millimeters, using the metric system in science. So, if we were practicing what the volume of a box is, that's 2 centimeters high, 3 centimeters long, and 4 centimeters wide, we do just like what we would do in math. We multiply those together. We multiply length times width times height. So, we have 3 times 4 times 2, which would give us a volume of the box with 24 centimeters cubed. Remember that we have to cube it because it is a three-dimensional measurement. If we are looking at volumes of irregularly shaped objects, let's say I picked up a rock outside and I wanted to know the volume of the rock. We would have to use something called volume by displacement or water displacement. And how we do that is by putting water in a graduated cylinder, seeing where that meniscus comes to first. We could slide in the object then and see how far the water level rises. By subtracting the 2, we can find out what the volume of that irregularly shaped solid is. Okay, so we see how much water was displaced or how much the water rises. Okay, so here, if we fill a graduated cylinder to 50 milliliters and drop in an irregularly shaped object, we can find where it goes up to. So if this is the 50 line and we're looking for the meniscus, we would count our lines up to see what the volume of the object is. So here's the meniscus, and it looks like it's at about 53 milliliters. So if the water level was at 50 when we started and it rose up to 53 milliliters, the volume of our object would be 3 milliliters. Mass and weight. It's a property of matter that a lot of people usually get confused, and that's okay. Mass and weight are not used interchangeably. They're two separate things. So, mass is the amount of matter in an object. So how much matter you have, or how much matter a desk has. Okay? Mass and weight are not the same thing because weight is a measure of the gravitational force that's pulling down on that object. So, if I went to the moon, I would have the same mass, but my weight would be different because the gravitational force is less on the moon than it is on Earth. So, mass doesn't change, but weight can depending on where you are. We measure mass with SI units. We measure mass in kilograms or grams. kilograms. And weight we measure in something called newtons. Okay, so 1 newton is kind of around 100 grams, approximately 100 grams. So that's how we can use our conversions if we're converting between mass and weight.